This is a transistor, okay. The arrow may be outward or arrow may be inward. If arrow is inward, then this will be PNP. If arrow is outward, then that will be a NPN. Okay. Yes. Inward mean toward base. If it is like blue arrow representing blue. Blue arrow is a PNP and black arrow is NPN. Okay, so that is the difference. If the arrow is beta, please, dear. If arrow is outward, away from the base, if this is a base, okay, this is a base. If arrow is away from the base, then that will be a NPN. If arrow is toward the base, then that will be a PNP. That is the difference. Okay, and arrow always represent the emitter. Okay, so this is a emitter. So that's why this will be a emitter. This will be a collector. And this will so this is a emitter, so that's why this will be a emitter. Okay, and this is a collector. So this will be so there will be a output voltage will be VCE. If this is out. Firstly, I have mentioned that about the input. Okay. VCE is a V out. Okay, this is a V out. V out will be a VCE or EC. Okay, for EC, as we know that okay. And this will be a VBE. That will be a input voltage, or that will be a EB. Okay, that will be a two possibilities. Okay, this will be an input, this will be an output. Okay. जी V इन के नीचे नहीं VBE और EB, ठीक है. They may be a B or EB. Okay. For this, this will be a forward bias. Okay. So for PNP, yes, plus minus plus. Okay, so this will be P will be at higher. Okay, so B will be at negative. So E will be high because this is emitter, this is a base, this is a collector. So E will be higher. So for PNP, EB will be for PNP and BE for NPN. But in this side, C will be a low, C will be higher for VC will be higher than VE for NPN, or VE will be higher for VC for PNP. Yes. So CE will be for because C will be high and E will, that is the reverse. Okay. C will be high and E will be a low. So that will be a C, and for this circuit they will be a EC. Mean E will be high, here E is high and C is a low. Okay, so that's the difference. Okay, and we have already discussed it in previous lectures too. Okay, so this will be a input, this will be a V out. Okay, what will be the input characteristic? Yes, what will be the input characteristic? We have to draw the graph. Okay, I in will be equal to IB. Here I in the that is different. Here input current will be IB. Okay, so I write in the form input is I in is IE. Input voltage is VBE or EB, and output will be, yes, what will be output? I out will be IC, yes, you are right. Okay, and V out will be CE or EC. This is for NPN and this is for PNP. Okay, always remember that. Okay, so so for input characteristic, this will be input current. Graph must be between input current. Input current is IB, and input voltage that is VBE or EB. Okay, so this will be we have to draw the graph between these two. Okay. Okay. So when IB is equal to when IB okay, this will be a like yes. As we know, this will be a forward bias. Okay, base emitter current will be always a forward bias. Okay, so this junction will be like a if it is a even it is a NPN or a PNP. For this, the base will be a forward bias. Okay, and the input characteristic will be a forward bias. So this will be like a input characteristic, the same as common base transistor. But what is the difference? I will explain. So IB with increasing the voltage, the base current will be increased. Proportional, because it is because why?
Simply width of the base.
1 minute. Because I will explain it later. Okay. Because EB junction will be forward bias. Okay, so EB junction will be a forward bias. Okay, got it. Here is a 2 junction. Okay, I have already explained this. Here is a junction. Yes. BC, and this junction will be a EB. This will be a forward bias, and this will be a reverse bias. Okay. Yes. Yes. This is a non-ohmic part. This ohmic part. That is exactly the same, because that is a diode. Okay. Diode. But yes, as your class fellows have a. Okay. And here, this is graph is between this and output voltage, and this is, as we have already discussed, the output voltage. We will keep the output voltage is constant. And what is the output voltage? That is a output voltage. What is the output voltage? CE or EC. Mean that is a constant. Okay. Now what is the early effect? Okay. And what if I change the voltage? What will be effect on that? Okay, that is different from the common base transistor. Okay. 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 So this junction will be a forward bias, and this junction must be a reverse bias. But this is not always. This is not always true. I will explain it later. This is only true for a. I have already explained this active mode. Okay, and this is true for a. 1 minute, please, beta. 1 minute. This will be true for a active mode. Okay, this is true for a active mode. So for active mode, this is for active mode. Okay. Okay. So this will be a characteristic for active mode, but when yes. Yes, this is a junction. This junction is a base collector junction, and this says EB junction. And this is emitter base junction. Okay. You may say that this is a base collector. This is a B. Sorry. If you are confused, this why there is a B is already so B E. Yes. Okay. Active mode. No, I will explain it later. I have already explained in a previous lecture, but I will explain it again. Okay, after some time. Okay. So this is the active mode. When a base emitter is a forward bias and base collector is a reverse bias, then that will be defined as an active mode. Okay. When this will be a forward bias and this will be a forward bias, then that will be a saturation mode. And so there are different. If both are reverse bias, then that will be a cutoff.
So what is the difference between saturation mode and active mode?
What is the difference between
saturation mode and active mode?
I will explain it. In saturation mode, both will be a forward bias. I will be explaining it later. Okay, both will be a forward bias. Okay. Okay. So early effect. Now early effect. Now I will explain how when we change the voltage, what will be effect. Okay. Yes, VC output voltage is, yes, what is the output voltage? That is VCE. Yes, VCE or EC, and this equal to, yes, this voltage is combination of this voltage and this voltage. Okay, there are two type of voltage, so this is the combination of VDC. Firstly, I should write the BE plus VBC. Okay. Okay. So VCB, if we are considering this, if VCE or EC is increasing, if I am increasing it, this implies that VBE, if BC is constant, BE constant, then BC will be, in 1 minute, AB. Yes, AB will be increase. 1 minute. BE or EB will be.
तो ये जो जितने फॉर्मूलाज पढ़ा रहे हैं इनका कोई न्यूमेरिकल नहीं देंगे?
न्यूमेरिकल मैंने कराया है तो वो दूंगा।
नहीं मतलब सिर्फ ये फॉर्मूला नहीं है इसका
नहीं, जिनका जो कराए हुए हैं उन्हीं के न्यूमेरिकल आए। इंक्रीज होगा नहीं, इफ आउटपुट वोल्टेज इज इंक्रीजिंग, एग्रीड, input voltage is output voltage, I have kept the output voltage constant, but in the case of the common base transistor, I have studied that if we change the output, it has a fixed output value, but what will be the change in this, okay, input characters. This is representing the increasing. If CB is increasing, then EB will be increased. Okay, because BE will be increased, then CB is increased.
Okay, decrease हुआ तो
then this will be decreased. Definitely, that will be directly proportional. Because if I kept this is constant, BC is a constant. Okay, if I kept the constant, then if I increase the CB, then EB will be a decrease. EB will be increased. Okay. From here, as I have already explained, total width WB, that is a total width, that is a constant, that will be is equal to, yes, yes, WF, yes, ये क्या है, WR. Okay, so 1 minute. When EB will be increased, EB is a, so EB increase, it implies that W forward bias will be increased and WR will be decrease. Okay. So it means the width size of base will be a Okay. Oh, sorry. Forward bias will be increase. नहीं ओके हमने पीछे आपने गलत बता दिया. हमने लास्ट टाइम पढ़ा था व्हेन ईबी विल बी इंक्रीज जब ईबी विल बी इंक्रीज विथ विल बी डिक्रीज. फॉरवर्ड बाइस है ना, विथ कम हो जाएगी. तो डब्ल्यू फॉरवर्ड विल बी डिक्रीज and W forward is between, yes, it is between. So W forward will be decrease. This implies that नहीं, ये ज्यादा बेहतर है. ये यहां रिवर्सिबल है, ये आपको पता चलेगा वो किस तरह इंक्रीज हो रहा है. Okay, so forward bias is increasing, then forward bias when EB will be increasing. Okay, VCB increasing. VCB increase is giving that this VEB increase, VB increase, VF with decrease, then electron will be move faster than from here. Okay. And okay, but IB will be 1 minute please बेटा. यहां उल्टा काम हो रहा है. इसमें क्या हो रहा है, आपके पास IE will be increase, सॉरी IC मतलब IC की तरफ जा रहा है, तो वो CB will be increase. I have already increased, but IB will be decrease. हाँ, अब E will be increase हो रहा है, लेकिन ये कहां जा रहा है, कलेक्टर करंट की तरफ. ओके, और बेस करंट विल बी अ डिक्रीज. नहीं समझ आए? इफ दिस इज अ फॉरवर्ड बायस, दिस विथ विल बी डिक्रीज, सो मोर एंड मोर इलेक्ट्रॉन विल बी मूव फ्रॉम हेयर. ओके, और no मतलब very few IB will be very small. Electron will be moved toward the collector current. Okay, and very few electron will become a base. So IB will be a decrease. Okay, so increasing the voltage.
I current है ना?
हाँ जी. तो base current will be a decrease. जी
इंटरनल स्टॉपिंग पोटेंशियल वो IB को नहीं इफेक्ट करेगी.
Width of the base.
आप कौन सी बात कर रहे हो, इसकी BC की बात कर रहे हो? तो ये करंट इधर ज्यादा मूव करना शुरू हो जाएगी ना.
ठीक है, लेकिन IB
अभी हम इनपुट करेक्टरिस्टिक देख रहे हैं, आउटपुट करेक्टरिस्टिक नहीं देख रहे. IB में कैसे चेंज आ रहा है, तो IB जो है वो हम सिर्फ वी आर जस्टिंग वी आर कंपेयरिंग दी इनपुट वोल्टेज विद द input voltage compared to input current. Input current is the base current, and base current is the decreasing. So if you are increasing the EB, if you are increasing the CB, if you are increasing the CB, then the current will be a decrease, and that will be move toward this, and vice versa. Mean this and this. This if this is a V1, this O2, this is O3, then VO1. Because current is increasing slowly. Here increasing fastly, here is increasing slowly. IB is decreasing. Okay, so VO will be less than VO2 and VO3. VO3 is a larger. When we are increasing the O3 output, when we will increase the output voltage, then current will be decreasing.